everyone. Yep, so we have Robin Bramley from Axis, which is one of the Alfresco Platinum partner. And he would be talking about Amazon, Alfresco and Amazon Web Services for us.
Thank you, Sujay. Yeah. So Sujay just introduced, I'm Robin Bramley, the Chief Scientific Officer at Axis. And today I'm going to be talking about Alfresco on Amazon Web Services. And some of the specific points I'll be covering are around migration of content, storage, and encryption at rest. But first, the obligatory word from my sponsor. So I work for Axis, we're a platinum partner, and we're sort of spread across the globe. So a number of different awards that we've won. And then my personal brag slide, so you might recognize me from one of these conferences. And I've also had articles published in Groovy Mag and D-Zone syndicate my blog. So we're going to be talking about the cloud, and who went to Summit 2013 in Barcelona. Okay, so at the Alfresco Summit in Barcelona, there was a keynote from Simon Wardley, and he introduced a mapping technique about strategy mapping, where you take a value stream and then project it across evolutionary states. And in essence, cloud computing was inevitable. So unfortunately, the arrows aren't really showing, but you have this genesis where you have a new novel idea. People then take that idea, you have custom-built solutions. As the system evolves more, you end up with products or sort of rental based around that idea. And ultimately, it ends up as a commodity or utility services. And then you get higher order versions of the pattern repeating. So the power generation is a good example of this, where it goes through and ultimately, we have power coming out of sockets, and there's pretty uniform standards across the globe. With computing, you started up with computers that are built to crack encryption. Some may say the NSA are still doing that, but that's beside the point. You then had things like ENIAC and Colossus, mainframes, mini computers, the PC, virtualization. These things come around in cycles. So virtualization is about running lots of servers on commodity servers. And you can't do a good presentation on the cloud without pulling in an XKCD. So this was from a few years ago, and basically they're saying the cloud's this server on the floor over here. Obviously, as an Amazon partner, I have to point out that Amazon's a bit more sophisticated hosting than that. So before I delve into the case study, we're going to do a quick Amazon primer. So Amazon Web Services is sort of a cloud hosting platform, and one of the basic constructs for security in AWS is the virtual private cloud. So all of our solutions use VPC. It's based around software-defined networking, so you can describe different zones and allow you to segregate the network. So you can have a demilitarized zone, you can have back-end zones, you can have zones that are allowed to communicate over a VPN back to your corporate LAN. Then there's CloudFormation, which is Amazon's way of treating infrastructure as code. So you can describe all your resources and template your stack. Alfresco have a set of CloudFormation templates, and Tony's in the room now, so if you want to know more about those, then I'll defer you to him. So Elastic Compute Cloud, to give it its full name that no one ever uses, or EC2, this is really where the virtual servers start coming in. So you have resizable compute capacity, and they are defined as different families. So the M class is a general purpose type of instance. The M3 is the previous generation. Those use Intel Xeon processors with the Ivy Bridge and Sandy Bridge family, and they have typically SSD storage attached to them. The newer M4 class uses Haswell chips, and that's EBS only. We'll cover storage in a minute. When you're looking to deploy Alfresco, where you really want to start is an M3 or an M4 X large, because the X large has 4 vCPUs, and that's the sort of basic unit of measure for an Alfresco enterprise license. And typically you'd have 2 of those and load balance them with ELB, so the elastic load balancer, and these are all the Amazon simple icons that I've used. So storage starts to get a bit more complicated. You know, EC2 is easy. You get a virtual server. Some of the storage classes have ephemeral storage. This means that it's storage that's actually attached to the physical server that your virtual machine's running in. So you can't guarantee that that storage will be available if your virtual machine shuts down or gets moved. EBS, or elastic block storage, this is kind of the SAN equivalent. So across the network, there's a big pool of disks, and they're providing block level storage to your individual EC2 instance. So this can't be shared between servers. The next offering is the elastic file system. So this is currently in preview in Oregon, and it provides a file level storage. So it's like a file share, and it supports the NFS4 protocol. So this can be shared across multiple Alfresco instances. And then at the next tier down, you have object storage. So S3, the Amazon Simple Storage Service, talks an HTTP protocol. It's a flat structure, so it's organized in buckets, and the objects have metadata wrapped around them. Alfresco, you can use all of these for storage, but what you choose for Alfresco, that's where you need to make your choices around things like indices. Typically for Solar, you want the indices on SSDs, and then for the actual content itself, if you're in a region with EFS, that's quite a good choice. But with S3, you typically need to look at then having a caching content store on SSD storage, either ephemeral or EBS, to cache and stop Alfresco constantly talking to S3. And lastly, there's Glacier. So Glacier is named for its cold storage. So it's near-line storage. You can use it for sort of DR backup. You can send backups to cold storage, but you have to make a request to get it retrieved from storage. So that takes time. You then have RDS, the Relational Database Service. AWS will manage your databases for you. So MySQL, Postgres. There are also enterprise options, Oracle, SQL Server, and with those ones you can either bring your own license or pay more on a sort of hourly rate to rent a license. And with RDS, it's a multi-AZ service, so you can have a master in one availability zone and then secondary nodes in a separate data center, so another availability zone within the same region. SES is the simple email service. Basically, don't bother with your own SMTP relays. CloudHSM is a bit more interesting because it's actually a hardware security module. So unlike every other AWS service, maybe with the exception of the next one we're going to get to, this actually you have to have provisioned so that someone will wire these appliances into your VPC for you. So it's very useful for master keys, and we'll talk more about encryption later on. But these use a SafeNet Lunar appliance, and there's a JCE provider, and being a hardware security module, the keys never actually leave the hardware. So all the encryption, decryption operations are done on the appliance, so you need to ensure high availability of these. Direct Connect is a lease line option. So Amazon have a number of Direct Connect locations. So in England, there's sort of Telecity and Docklands. You pay for a lease line connection to there, and then the traffic goes up an Amazon backhaul to Ireland, and basically reduces that contention with your internet line. Very useful if you're shifting a lot of content. So import-export was a service Amazon introduced in 2009, and basically you could ship them 2 terabyte disk packs. You could encrypt them using TrueCrypt, and then they'd copy the contents onto S3 and return you the disks by courier. Last year, they introduced the Snowball, so a luggable disk pack. These were 50 terabytes. when they introduced them last year. Last week they've just announced 80 terabyte ones. So the good thing here is because it's Amazon owned, you don't have to invest in sort of transient hardware just to migrate across to the cloud. And they wipe them following good security practices, and they're encrypted. So I think I'm about to get a 10-minute warning. So moving on to the case study. So a project we did about 2 years ago was to migrate a global top 20 publisher to Amazon. So at the time, $1.5 billion in revenue and split across 20 countries. This was a program with a number of different streams. So the first one was an on-premises DAM replacement, and that was where kind of the bulk of the migration effort came in. We then had a second project in the program where we were introducing rich media handling capabilities for them on Alfresco. The third one, encryption at rest, which we'll cover in more detail, underpinned both of those. And because everything was being run in parallel, we had a reconciliation at the end to ensure that there was content model harmonization. The migration did involve a truckload of disks because Snowball wasn't out at that point. And it was a multi-step process. So the first thing was to get to the 35 terabytes of content out of the existing DAM system, transfer it across using import-export. Then we had a metadata preparation step. So if you're familiar with the bulk file system importer tool, it can accept properties XML files. So we had to interrogate the existing DAM database and then prepare all the metadata in XML form. Once that was there, we ingested it into Alfresco. At this point, it was all unencrypted in S3. So the final step was a migration step to move it from an unencrypted bucket to an encrypted bucket in S3. So the encryption was quite a lot of fun to do. And I'll start with some basics. So symmetric encryption is where you take plain text in red and you end up with ciphertext in green. And this is done by passing it through an algorithm with a key. So this uses a single key, typically known as a secret key. Asymmetric encryption, or public key cryptography, and again the arrows have kind of faded into the background. For encryption, you have your plain text in red, you have a public key, so the encryption takes the public key and kind of addresses it for the person who owns the other side of the key pair, the private key. So you end up with ciphertext. You take that ciphertext, apply the private key, and then you can decrypt it to get the plain text. So this is, PKI in essence. And is anyone familiar with the innards of the Alfresco S3 connector? I've got a nod at the back there. Oh, and a couple more hands. So Alfresco has a content store interface. You can plumb in multiple content stores. So you can do things like have a primary content store on SSD, a secondary content store on, say, S3, and then use content store selectors to help cascade down. So the S3 connector implements the content store interface, provides a reader and a writer. There's a service adapter that deals with essentially jet set and talking to S3, and then a stream listener that handles the actual writing to S3 once it's sort of streamed to temporary working storage. So S3 provides a number of encryption options. On the left-hand side, we've got unencrypted. That's no use in this case. We then have server-side encryption, and that's where Amazon perform the encryption and look after the keys for you. Again, no use for this customer. SSEC is server-side encryption with customer-supplied keys. So Amazon do all the heavy lifting of the encryption, but you supply and maintain the keys. And then lastly, on the right-hand side, this is client-side encryption, so it's completely transparent to S3. You encrypt it and you look after the keys. And SSEC was new in June 2014 when we were doing this part of the project. So the Alfresco Enterprise S3 connector can do unencrypted. It can also do server-side encryption with a single configuration property. And the Alfresco Enterprise CryptoDoc module can do the right-hand side. So that sort of gives that transparent nature to it. But there was no offering for SSEC. So after a couple of conversations with Brian Remington and Greg Milan, we ended up implementing that. So you've got the way we did this was to apply good cryptographic principles. So the Open Web Application Security Project provides a number of storage rules. So the first one is using strong algorithms, storing the keys separately from the data that they protect, using independent keys when multiple keys are required, and then sort of protecting and rotating keys. So another bit of sort of introduction. So envelope encryption uses the best of both of symmetric and asymmetric encryption. So secret key encryption is fast, so it's great for encrypting the content, and asymmetric encryption is very strong, and the decryption takes a long time, so it's harder to crack. But consequently, you want to protect small things with it. And the envelope encryption uses the separate keys. So we've got the envelope keys to protect the data, and then the master keys for the asymmetric encryption. So we generate an envelope key, encrypt the content, protect that envelope key with the master key, and then persist that envelope key. Now this took a few modifications to the S3 connector. So the most important ones are the key operation service, which is a facade onto a whole load of other collaborator classes that's hidden. And then we had to extend to have a crypto S3 service adapter implementation. And then we had to break a load of the construction logic into a factory class so that we could choose our crypto S3 service adapter implementation based on configuration. So the encryption at rest, unfortunately the colors aren't great on this projector. So we've got the master key store on the left-hand side. That's looking after the master keys. That was the CloudHSM, the hardware security module. We've then got the S3 connector modified with SSEC support and the JetSet library. Encrypted assets in S3, and then the encrypted envelope keys stored in the Alfresco database. To get there, as I said, we had to do that migration step. So we had a standalone migration tool written in Groovy, and this could fetch master keys from CloudHSM, write the encrypted envelope keys to the database, and also using JetSet perform a server-side copy. So in S3, rather than streaming the content back and telling it to go and encrypt it, if you pass the correct headers, you can tell it to copy and encrypt on server side, to move it from one bucket into another and encrypt it. So in terms of closing comments, the S3 connector encryption modifications have been contributed back to Alfresco, and there's a set of references there and contact information. And I think I've got about 2 minutes for questions. Tony.
You said that the content is stored encrypted, right?
Yeah.
What about the indexing? Is Solar indexing the content for full text search?
So in this case, they were concerned with at-rest encryption. So yes,
You can choose between both.
so only the content is encrypted on S3. Obviously, the indices and then the plain text tokenization of the content is unencrypted in Solar.
So the indexing is done before sending it to S3? Or?
So they're using AIS. So AIS also is configured to have the S3 connector in. So when it fetches a content reader, this content reader, because it's using the sort of key operation service, it will get a decrypted stream to index. Martin.
You mentioned TrueCrypt.
Yeah.
Is TrueCrypt not obsoleted now?
So that was on the old import-export service, and yes, that's obsolete. So on the new Snowballs, they use AES encryption. Ian.
You mentioned using a simple email service. Just to have a caveat, if you do inline images, then the simple email service won't send your message. So, for example, you've got
So for the recording, the point from Ian was that the SES doesn't work with inline images. So if notifications for discussions include an image, then they're not sent. So in that case, yes, you would want to have an SMTP relay. And I think that's about time onto this one. So thank you very much, and I'm around, so grab me afterwards.